Section 2.3, Writing Equivalent Fractions. Equal fractions with different denominators are called equivalent fractions. An example is 4/6 is equivalent to 2/3. They have the same numerical value. Let's try a problem. Write a fraction that is equivalent to 5/8 and has a denominator of 32. Well, you'd have to decide what times 8 will equal 32. The number is 4. Whatever you do to one side of the fraction, you must do the same exact thing to the other side of the fraction. So, if we take a look at the 5/8, multiply both the numerator and the denominator by 4, we end up with our equivalent fraction 20/32. Example 1. Write 3/5 as an equivalent fraction that has a denominator of 45. 5 times what number equals 45? That would be 9. And again, whatever you do to the bottom, you must do to the top of the fraction. So we have to multiply both 3 and 5 by 9. We end up with 27/45. Example 2. Write the number 4 as a fraction that has a denominator of 12. The number 4, which is a whole number, can be written as a fraction by writing it as 4/1. You can do that with any whole number by writing it over 1. So if we write the number 4 as 4/1, and then recognize that we have to make the denominator into 12, we're going to multiply by 12. So, we write 4 as 4/1, multiply the denominator by 12, and therefore multiply the numerator by 12. So our equivalent fraction is 48/12, which equals 4. Let's have you try a problem. Write the number 6 as a fraction that has a denominator of 18. You want to do the same thing as we did in example 2. Write the whole number 6 as a fraction by putting 6/1. Then, because our denominator needs to be 18, we're going to multiply by 18. And because we're multiplying the denominator by 18, we also have to multiply the numerator by 18. So, we're going to do 6/1 and then times 18. We end up with 108/18. Writing the simplest form of a fraction means writing it so that the numerator and denominator have no common factors other than 1. This is also known as reducing a fraction. Example 1. Write the fraction 15/40 in simplest form. The way you do that is by determining the largest factor, or the greatest common factor between the two numbers, and divide both the numerator and denominator by that GCF. Well, 15 and 40 are both divisible by 5. So we would take 15 divided by 5 and 40 divided by the same number, 5. We end up with 3/8. And 3/8 cannot be further reduced because 3 is prime and 8 does not have 3 as a factor. Let's try another problem. Let's use the fraction 16/24. Write the fraction in simplest form. Well, you may have immediately thought of the GCF amongst 16 and 24. It is 8. If you divide 16 and 24 both by 8, you end up with 2/3, which is simplest form. Now, if the only number you could think of was 2, and you divided 16 and 24 by 2, you end up with 8/12. There's no problem with that, but just know or recognize that 8/12 can be further simplified. 8/12, you could divide that by 2 as well. So we end up with 4/6. And then again, notice that 4/6 can be simplified as well. Divide by 2 again. We end up with 4 divided by 2, and 6 divided by 2, which gives us a final answer of 2/3. No matter how you do it, you're going to get the same answer. The second method just takes you a little bit longer. Example 2. Reduce or write in simplest form the following problems: 8 over 56, 15 over 32, and 48 over 36. For part A, we have 8 over 56, and you'll notice the GCF amongst the two numbers in the fraction is 8. So 8 divided by 8 and 56 divided by 8 gives you an answer of 1/7. 15 over 32. The only common factor between 15 and 32 is 1. The factors of 15 are 1, 3, which does not go into 32, 5, which does not go into 32, and 15, which does not go into 32. So our final answer is 15 over 32. Finally, we have 48 over 36. The GCF between the two numbers is 12. So if we divide both by 12, we end up with 4/3. Let's try some review problems. For numbers 1 through 3, write an equivalent fraction with the given denominator. 1/2 equals blank over 32. Number 2, 2/3 equals blank over 12. And number 3, 6 equals blank over 11. For number 1, we have 2 times 16 equals 32, so we have to do 1 times 16. We end up with 16 over 32. Please note that if your denominator goes from smaller to larger, then you're going to multiply. Number 2, we have 3 times 4 equals 12. Therefore, we have to do 2 times 4, which equals 8. So 8 over 12. And then finally, number 3, 6, which is a whole number, can be written as a fraction by placing it over 1. So 6 over 1. And we have to take 1 times 11 to get 11. So we have to do 6 times 11 to get 66 over 11. Continuing with the 2.3 review, for numbers 4 through 6, write the fraction in simplest form, i.e. reduce each fraction. Number 4 is 6/9. Number 5 is 24 over 64. And number 6 is 85 over 75. For number 4, 9 divided by 3 gives us 3, and 6 divided by the same number 3 gives us 2. 2/3 is the reduced form of 6/9. Notice that if we are going from a larger to a smaller denominator, that we divide. Number 5, the GCF between 24 and 64 is 8. So if we divide the numerator and denominator by 8, we end up with 3/8. Then finally, number 6, 85 and 75 both end in a 5, so they are instantly both divisible by 5. 85 divided by 5 gives us 17, and 75 divided by 5 gives us 15. So our final answer is 17 over 15.